Hello, in this video we are going to solve question number 4 from section B, which was asked in the Indian Certificate of Secondary Education, 2010 Computer Application Exam. It's a basic binary search problem where we have been provided a sorted integer array of size 10. We have to search a number entered by the user using binary search, and if we are able to find it we have to display the number with its position, and if we are unable then we have to print a message that search element was not found. Before we code this problem, let us discuss what is binary search, how does it work and how efficient it is. It is imperative to understand the small details of binary search, cause it is one of the favorite concepts not only of the people who set your exam paper but also teachers who conduct practical exams and viva. Binary search is a divide and conquer algorithm to find the desired element in an already sorted data structure. This data structure can be in any form: array, structure, linked list, trees, so on and so forth. So, without further ado, let's quickly understand how this search algorithm works. Let's say we have a sorted array which has 6 elements and we have to search whether 10 and 5 are in this array or not. Traditionally, we would have iterated by checking each and every element of the array, and on 5th and after the 7th iteration we would have come to know that 10 is present in this array and 5 isn't. Too many numbers of iteration are not a problem provided the size of an array is small, but as the size of an array increases, sequential search will not only take more time to generate results but also would consume a lot of RAM while doing it. In contrast to this, binary search would require 3 variables to do so: the lower limit, the higher limit and middle. The lower limit will always point to 0. The higher limit would always point to length 1. In our case it would be 5, and middle variable would point to mean of lower limit and higher limit. In this case it would be 2, initially. In first iteration, it would check whether the value at middle position of an array is equal to 10. Right now, it doesn't. The value at middle position is 6. That means the number we are searching, which is 10 here, will not be found between the lower limit and middle. So, we need to change the values of our variable. Since we have to go in the right direction, so our lower limit would be updated to middle plus 1. Always remember, whenever we have to go in a right direction the value of lower limit would be changed. So, now lower limit would be updated to 3. The value of higher limit would be unchanged as of now. That means it would be 5 for some time now. Again, with these updated values we would calculate the value of variable middle, which would be 3 plus 5 divided by 2, that means 4. Again, we would compare the element at middle position with the number we are searching. So, at 4th position we have 10. Voila, we found it. I will bring something into your notice that the sequential search took 5 iterations to generate this result, whereas binary search only took 2 iterations. Coming back to searching value 5 in an array. We already stated that a sequential search algorithm would take 7 iterations just to figure out that 5 doesn't exist in this array. Let's inspect the binary search algorithm to find out how many iterations it would take to find out that 5 doesn't exist in a given array. Again, lower limit would be 0, the higher limit would be 5 and middle value would be 2. Let's compare the element at 2nd position with 5. It doesn't match, the value at 2nd position is 6. With that in our knowledge now we know that in our 2nd iteration we have to go in left direction. So, now the value of lower limit won't be changed, but the value of higher limit would be updated to middle 1. You know why we do middle plus 1 while going right and middle 1 while going left? Because we already compared the values at middle position, so there is no point in again comparing the values at the middle position. With this in mind, let's update the value of higher limit to middle 1, that means it would become 1 now. Again, let's find out the middle value, which would be 0 for now. On comparing the element at 0th position with 5 we would come to know that 5 is not present at 0th position and we have to go into a right direction to search 5. And for that we have to update the lower limit to middle plus 1, which is 1, But this would make the values of lower limit equals to higher limit, therefore the binary search will collapse and it would stop searching anymore. That means in 4 iterations the binary search came to know that 5 is not present in an array, whereas sequential search took 7 iterations. It is not hard to know which of the algorithm is more efficient. The teacher who would be taking your Viva might ask you to comment on the fact that how binary search is more efficient when it is using 3 extra variables, straight away. Whereas, sequential search is using only 1 variable. The important thing is if the size of an array is small then definitely binary search algorithm would be more costly to your RAM, but if the array size is too big in that case 6 kilobytes of space that these 3 variables would take is not a loss but a strategic win. 3 important points you must always remember while performing the binary search are as follows. Point number 1 is that array should be sorted. Point number 2 is that if you move right, update the lower limit to middle +1 and if you move left, update the higher limit to middle -1. And third point is that binary search algorithm will work till the value of the lower limit is lower or equal than higher limit. With that, let's quickly code out this problem. I know I have eaten up your precious time till now explaining binary search, but this was necessary to lay the foundation and trust me it would make the process of coding out the problem and understanding it much easier from here. Let's import the util class from scanner package. Scanner package would be used to take input from the user. If you remember, question states that a number which we have to search would be entered by the user. The other package is I.O. It is used for simple printing messages to the console. With that, let's quickly create a class by the name binary search and jump inside the main function. If you want to know why do we write the public static void main, you can watch the suggested video or I would leave a link in the description. In Java, we can't access or use any function which is a part of any class without creating an object of that class. To take input from the user we will need to use the next int from the scanner class. So, in order to use it we need to create an object of that class. I have kept the name of the object as KB, for me KB stands for keyboard. Since the size and values of an array has already been provided to us, let's quickly initialize array and some other variables which we will use in order to successfully run binary search. In num array we would be storing all the values. LL stands for lower limit, its value has been set to 0. As always. Similarly, HH stands for higher limit, since we have 10 elements in our array, we would set to 9. Next variable is middle which has been set to the average of lower and higher limit and the last variable is flag which has been set to 0 initially. The purpose of using this variable flag is to change its value and come out of the binary search as soon as we find the desired number, and if we aren't able to find the desired value, in that case too, unchanged value of flag variable will help us determine the outcome of binary search. Let's ask the user to enter the number and with the help of KB which is a scanner class object let's save the value in I. Do you know why every now and then we get a question on binary search in our board exams and practical exams? It's because it is a classic and easiest way to find out whether a student knows the concepts of while loop, if, else if and else. The concept of binary search as such is not so difficult, how and what we use to implement plays much more important role in terms of laying the foundation of your future studies. As I have already told you that binary search will work till the values of the lower limit is less or equal to higher limit, and easiest way to make sure of that is to use while loop. While explaining how binary search works, I told you that every now and then we would compare the value at middle position to the value we are searching, and if we are able to find the comparison to be true, then we have to take certain actions. To do this we will write up a if condition to compare the values and print the message found and the position where we found it, if it's true. After printing the message, we would change the value of flag to 1, to make sure later whether inside the while loop we found the value or not. Since, right now we are inside this if condition, that means we have found the value and there is no need to further continue with the while loop. So, We will break the while loop and come outside of it. Next, if we didn't able to find the value in the if condition, so we have to find, do we have to go into left direction? For that we would check that value at middle position is greater than I value. If yes, we would update the value of higher limit. If both if and else if condition doesn't hold true, that means we have to now move into the right direction and subsequently update the value of lower limit. With that we have completed our one iteration inside the while loop. Till now either we have found that our value inside the array, or we have decided to either go in left or right direction. With new values of lower and higher limit we need to update the value of middle variable for further computing. Let's say entire while loop has run, we may have got the value or maybe not. If we have found the value, then also we would break the while loop and come out, and if we weren't able to find the value, and lower limit becomes greater than higher limit, then also we will come out of the while loop. Now technically we aren't sure out of two reasons we just discussed which one brought us out of the while loop. So, to make sure of that we would check the value of flag. If the value of the flag hasn't been changed till now, that means we couldn't find the desired value in our array, and should display the message that value wasn't found. If you liked this video, subscribe to my YouTube channel and press the bell icon to get the latest updates.